Hello, everybody. All right, I want you to imagine this. It's early summer. You're just getting off work. It's hot, it's dry outside, and you're ready for a couple of cold beverages on your favorite rooftop patio. Maybe you're gonna go out for an early dinner on an outside patio with your family. As soon as you get there, you feel a cold gust of wind. You look up into the blue Alberta sky, and you see black clouds billowing up on the horizon. You know a hailstorm is on its way. Your phone lights up. Your social media is going nuts with people posting pictures of tomb-sized hail that's falling from the sky, crashing into their windshields, demolishing their house siding, and destroying their rooftop-mounted solar panels. Hi, I'm Steven. This is Sanuka. This is Hi, I'm Jeffrey, and together we are Megatech. We've been working together for the past 2 years on our unique solar panel protection system, which is designed to protect vulnerable surfaces from falling object damage, such as hail. So it's no secret that Calgary is in the midst of hail now. In fact, we see one of these hailstorms no less than 5 times every summer. So the picture you're seeing behind me here is actually the 2020 hailstorm that we saw here in Calgary. This is the 4th costliest natural disaster in all of Canada. It cost insurance companies $1.2 billion worth of home and auto damage as well. So Alberta is the sunniest province in all of Canada. So what that means is there is a lot of investment and development happening in green solar energy. So again, it's no real big secret that hail doesn't exactly mix very well. Sounds like my mic went off, sorry. Sounds like hail didn't mix very well with solar panels. So in fact, in order to replace a mounted residential solar panel, it can cost up to $3,000. In order to repair a commercial solar panel, it can cost above $30,000. That's a lot of money. So before we get into the details of our capstone project, I'd like to talk a little bit about how we came up with the idea. So it all started when we were talking with city students and electrical engineering students in his first year, Kevin Dirksen. So he was currently working on commercial solar arrays. He was fixing them, and he noticed that there was an issue with falling object damage on the solar arrays. As we started talking, we realized we might have a capstone idea. He said that he would be able to create a mechanical device that would sit on the side of a solar array that would deploy a protective mesh that would be able to cover and protect the solar array upon a signal. And when it receives another signal, it would retract that as well. As we continue talking, we realized that protecting solar panels wouldn't be the only function here. We might be able to get this to protect vulnerable farmers' crops, or to protect exposed vehicles in dealerships, or even protect homes. So, as we get into the further details here, I'm going to give the mic over, and we're going to look to a high-level overview.
Thank you, Steven. Hi, I'm Jeff, and so our idea of our solar panel starts off with our networking system. Our networking system will definitely have a firewall for security reasons, of course, and then the heart of it, the weather API. The weather API will find the source code to tell if it's hailing or not. And then next we have the admin to access this server in case it needs to change, or end consumers eventually. We also have a backup API system just in case if the primary source does go down. So how does the weather API system work is that in a main server, it will be searching for a weather source that would tell us if the source, if it's gonna hail soon or not. So even if it does hail or not hail, it will write a 0 or a 1 into a notepad, which translates to a yes, it will hail, or no, it will not hail. Now, this notepad of 1 and 0 will go into the Raspberry Pi that is attached to the solar panel covers, and this Raspberry Pi. This Raspberry Pi would then will read this file. If it's 0, yes, it's going to hail soon. Then the cover will cover the solar panels. Now, if it was a no, if it gets sent a one as a no, if it's covered, it goes down, and if it's not covered, that will happen. Here's a quick video demonstration. This is our video demo of our capsule project. Here in this monitor is our Raspberry Pi with connection to the two LEDs right here. And then this will be representing our servers. This text file with the one will represent our weather forecast as a no hail has happened yet. As we send this file over to the Raspberry Pi, you'll notice that this file has popped up. And if I should run this, and it said red light on, you might not see it, but here is the red light. So what happens if the condition changes and it turns to hail has happened? So that would come out as a 0. And we would have to make sure this would be always constantly switching. Send this file over. For following this text, it would represent a 0 and this. Turn on the next one. So that's a demonstration if it was in a large, far distant farmer and you're in the city. So what happens if you want to control this personally with, I don't know, Google or Alexa? We have a live demo here. Unfortunately, the live demo has been demonstrated over here, so LED would be not seen in person as. Yes, sir. I forgot my password. Sorry about that. Give me a quick. Oh, there you go. So this would be part of the Raspberry Pi. As you can see right now, it would be a 0. And once I run this, as I'll try to hold this up, the blue light will run on. Now, if I were to change this to 1, and then the red light will be on. As you saw it, the red light is actually hard to see. But it would be turned on and the shutter would be closed. That would be a demo for every.
You go back to the PowerPoint, please. Okay, perfect. So for me, the main thing that I learned in this capstone project was to implement a topology. And the main thing that we all had to do, starting from the first networking class, was when you adding a router or anything, you were making it less redundant. So what I had to do is I had to add 3 ISP routers and also making 2 branch routers and adding GRE tunnels to each of those branch routers as well. Just in case one of the main routes were to go down or anything like that. And as you can see, there's 2 VPC clients there. and then access the Raspberry Pi. So how that works is I would have to pick up to R1, which is actually the solar panel system, which is what the Python script is, what Saluja is going to talk about a bit here. And then making sure that everything is connected to the client so they can deploy the device, the protection system.
So, early on, at the very beginning, Stephen found a weather source, which is based on curve, that can pull data onto a screen, like the one that's showing on the left. But the problem with this data source is that it will pull hundreds of variables, but it doesn't have the hail variable. It will show you the humidity, it will show you temperature, a whole bunch of other things, but it will not have the hail because it's actually written in the United States or somewhere they don't have hail, I guess. So what happened is that I had to go and find a programming language that I can use to extract data. We had two issues. One is that there's hundreds of variables every single time we run, and we run every couple of minutes. So there are going to be thousands of variables at the end. So what we did, we decided to go with Python because we are more familiar with Python than Java. We had experience in both Python and Java for the first time at this stage, and we decided to go with the Python. And we were able to use, this is just a part of the code, but we were able to use this code to strip certain data, remove unwanted variables, and use a conditional logic to decide whether the hail is forming or not. That conditional logic is our own because it basically uses like a couple of variables. If it is the temperature and certain conditions are met, it will either produce a 0 or 1. The 1 will say, yes, there's hail, just like Jeff just showed you. If it is 0, it will say no hail, so it will restart the device. So in terms of lesson learned, during this project, we all learned, we came across a couple of challenges, both professionally and personally and also technically. For me, the biggest lesson I learned is that, specific to this project, is that the Python databases and the Python, what you call the way that the sources sometimes are not standardized. So in order for us to use it, especially as a networking student who's not in programming, it took me a lot of work, a lot of research, and go through multiple sources to figure out how to make it working. So that's the biggest challenge I faced as personally. And I'll pass the mic to the.
And then, so for technical skills that I have learned and gone through was that I actually worked with a Raspberry Pi to install our systems and stuff. At school, we use our home system or the school laptop all the time. So using something a little bit different can change the aspect of it a little bit different. And then as you saw there was a lot of Python code, each one different for each case scenario. And then I also had to do a slightly electrical engineering with the Raspberry Pi, with the breadboard that showcased LEDs of the mechanical parts of it. As professional skills I took in is communication is very important no matter how, like, no matter the situation. The more communication and more understanding you get, the better of the project and the evolved project goes along. And while communicating with people, I learned that, or with my teammates, is that instead of standing still working on a project, waiting for someone to finish their part before you work on your part, there's always a way to move the project along, sidestep, and do something to make sure the project is moving slowly or fast, depending with my own skills.
Yeah, so some of the challenges and some of the skills that was able to develop, I think part was a lot of Python scripting, and one team up here said it pretty best, and that working for a reason. So scripting really is my favorite thing to do, but we went in and tackled it head on. Also learning how to manipulate code and web APIs, and also how to scrub Google from Linux, looking for particular web data in areas as well. Another one of the things I also learned is how to be a good leader, or how to be a good manager. So I was lucky enough to be elected as team lead for the team for the duration of the project. And the first thing I thought is, what would a good team do? So I wanted to act ultimately as support the entire team. So the first thing I wanted to do is make sure that we always had clear goals. Our team meetings were always held on time. They always had goals, making sure to always record what we were doing in those meetings so that there were no questions or there was always clarity there to be had. And I also wanted to make sure to get rid of all the extra static noise that might be distracting the team members from being able to achieve what they wanted to do. So by that, I mean, I wanted to take care of doing all the end of sprint documentation, taking care of the PowerPoints, taking care of the team minutes, making sure that all those little extras are just completely done or ready for the team's input, so they don't have any questions when it comes time to take care of that stuff. So luckily, I had an amazing team of gentlemen to work with here. We didn't have any interpersonal conflicts that we needed to deal with. Truly, I think the experience was probably one of my best experiences as a team lead.
So my key lessons learned was, I had an IB lesson 13 into just trying to troubleshoot the topology itself. Instead of spending long hours on it, or 8 hours, I would have to just sit down and just think about what I did wrong. Or I would actually contact one of these guys for help, which actually helped out quite a bit. And in the long run, that's what happened. And then we finished the topology. And so our biggest obstacle was learning together without being together, was literally asking for help. And I feel like we're strongest when we're together, because we fixed any issues that we had during our meetings together, and we got through it pretty fast, let's say. After presentation, I'd like to thank Kevin Dirksen and all the SAFE instructors and friends. I don't think there's any family here, but you guys have any questions?
So I apologize if I didn't quite catch this. What would happen in the event of a power failure or some other thing like that? What would happen to the panel guards, for lack of a better word?
In the event of like an on-site power failure. Well, the nice thing about being right beside solar panel arrays is that you'll be able to tether into the actual electrical source as well. So as usually, if it's being installed in the residential area, it's not going to be much. If it's being installed on a solar array panel, like somewhere out in the field, then hopefully you'll have enough panels that happen to damage. You'll be connected directly into the source itself, and there wouldn't be much of a draw on solar panels to run the system itself.
Cool. And what I was getting at with that, very often we have mechanical devices, either power them off, they have a fail-safe condition. And so one of the things we can think about is the thing goes off and there's some sort of, spring or other physical device that would actually bring the cover up automatically. This is a guaranteed fail-safe kind of thing.
That's an excellent idea, as well as, the involvement of the other state student being the electrical engineering program. He's in his first year. He's also doing an electrician as well, and he's worked on solar panels already to fix them. So he's got a plan in mind for the fail safes as well. So I think we got the mechanical side coming. Any others?
Sure, question. So I understand that the event fund is 70 years old. So do you guys look to expand to unavoidable condition as well? for the rain, heavy snow, or the heat wave?
So, yes, so the Python code that we wrote, I have looked into the two sources. There's actually two sources. One is the Google API and the other one is the Cloud. Both of those sources have the ability to detect multiple variables. In fact, the first time when I ran for 15 minutes, my VM crashed because it was pulling so much data. It has humidity every minute, and it has like ceiling temperatures for ceiling height and some including aircraft data, like the aircraft weather data. So it has ton of data. So the only thing we as a team, as a group, the only thing we need to do is to simply add in a little bit of more code to the Python, and you can completely, yeah, you can detect hail, you can detect snow, we can detect even heat, because maybe solar panel has some kind of electronic part that might melt in a summer, I don't know, like something that needs to cool down. We can put all of that into our Raspberry Pi.
There's also, my portion is that the Raspberry Pi or anything, it can have hooked onto a wetness detection system as a fail safe, so like if it starts splitting too much or if it's cold, there's a temperature sensor that could also trigger a cover situation. It doesn't have to be just the Python code searching whether, because you know some section of Calgary may have hail, some section might not have hail. There's also these kind of small mechanical attachments that can be added to it to a fail safe of, hey, there's too much water or it's getting too cold or something like that.
All right, so you mentioned that you have a mechanical engineering student you're working with. What is your project at a point where that can be handed off to him and he can use it to control his capstone? And if not, what is the gap?
Ultimately, I mean, there's a list of nice to haves that we're still working on, but ultimately, we feel like we're pretty much there. We've got the basics of what we need to do. We have some fail safes that we're working on and some redundancies that we're adding to it as well. But yeah, I do believe that Kevin is able to step in once he's in his second year and take over the reins and work on the mechanical side of things.
The only change that we would probably have to have is the final Python code where it controls the LED. Instead of LEDs, the Python would control a motor that runs on and off, turning one way, like one it will turn one way, if zero will turn the other way, if it's already closed, then it will turn kind of situation. So that's the only situation that we would have to change if we were to hand over this project to the other students or other classrooms.
Thank you.